Okay. In this video, we are going to talk about the biogeochemical cycles. So what are the nutrients that we need and how do they move throughout the environment? So this may be a lot of review. You've probably seen the water cycle, the carbon cycle, the nitrogen cycle, the phosphorus cycle, and the oxygen cycle in previous science classes. So this may be a lot of review. The first cycle we're going to talk about is the water cycle, the hydrological cycle. What's going to happen is we are going to move water throughout the environment. So water, if we start out, exists in streams, lakes, oceans, bodies of water. As they heat up, they're going to convert from liquid water into gaseous water, into water vapor. And this is going to move up into the atmosphere through the process of evaporation. This evaporation is going to condense into clouds, which will, after enough builds up, will lead to the production of precipitation, of rain, of sleet, of hail, of snow. So this precipitation is going to come back down to the earth. And it can come in a couple different spots. Sometimes it lands on the soil and gets soaked in, which leads to percolation and groundwater. So if you have a well, this is how your well fills up, through water melting into and soaking into the ground. Other times it can land on harder surfaces like the mountain here, and it will run off into a larger body of water. You can also have evaporation from plants and animals, and we call this transpiration. Or in humans, you often think perspiration as sweat. But this is transpiration is the movement of water out of a plant, kind of like plant is sweating. And again, this is going to go back up into the atmosphere, cause more condensation, and produce more precipitation. The next cycle is the carbon cycles. The carbon cycle and the oxygen cycle, we're going to talk about both of them, but they are kind of linked. So carbon cycle is going to talk about multiple different forms of carbon. So carbon dioxide, fossil carbon, soil carbon, carbon in the oceans, and it's going to move around in a very large cycle. So if we start out carbon dioxide, everyone knows what carbon dioxide you're currently breathing it out. It gets produced from cellular respiration, something we talked about at the beginning of the year, as well as human emissions. So as this carbon dioxide goes into the atmosphere, it has a couple different options. It could be sucked up by plants during photosynthesis, or it could be absorbed by things in the ocean through marine photosynthesis and stuff like that. From there, it has a couple different places to go. It can be absorbed into the soil, it can go back up into the atmosphere, it can be absorbed by different organisms. If it is absorbed into the soil, it usually can become either soil carbon, or if it sits for long enough and has the right conditions, can turn into fossil deposits and things like that. So all of our coal, all of our oil, all of our natural gas is a result of different carbon-based organisms dying and being compressed into a mostly solid carbon source. So that's why whenever we burn fossils or fossil fuels, we get more carbon dioxide back into the environment. And this has been greatly expanded by humans. So especially through the process of respiration and the process of human emissions, as we put more carbon dioxide into the atmosphere, it's going to increase that climate change that we had talked about in the last unit. More greenhouse gases gives more carbon dioxide, which makes hotter temperatures. But the respiration and the photosynthesis is something we are going to talk about here in a couple slides. The next one, the oxygen cycle. Again, just like the carbon cycle, we are moving oxygen throughout the environment. So we have oxygen in the air, it gets absorbed by organisms. Those organisms can either use it for cellular respiration to produce carbon dioxide, or it can be absorbed and the organisms could die. So the oxygen and the carbon dioxide go into the soil. From there, it can be released back into the air as carbon dioxide. plants absorb that carbon dioxide to make new oxygen. So take a moment. What's one common theme you notice between the carbon cycle and the oxygen cycle? So this common theme is the movement of oxygen and carbon dioxide through cellular respiration and photosynthesis, something we've talked about already. So oxygen and carbon dioxide cycle through the environment through organisms. So as we produce carbon dioxide, as you're breathing out, the plants are going to absorb this carbon dioxide and use it for photosynthesis. Photosynthesis produces oxygen, which again fuels our cellular respiration. So you can see that without one, the rest of the cycle would not exist. Without plants, we would not be able to get the oxygen we would need to survive. So that's why looking at deforestation and loss of things like the Amazon rainforest are really important, because with this loss of one part of our cycle, the rest is bound to collapse. So the next one we're going to talk about is the nitrogen cycle. Nitrogen cycle is going to be the movement of nitrogen. So nitrogen as gas. The air is actually made up of more nitrogen than it is oxygen. Nitrogen in fertilizers, nitrogen in runoff, as well as this nitrogen that gets absorbed into the soil. So your waste has nitrogen in it, and as it goes down and starts to be broken up, it gets converted by bacteria into a few different forms. So we start out as ammonia. This ammonia gets turned into nitrite. Nitrites get turned into nitrates, which are better able to be absorbed by plants. So we get this kind of cycle where the bacteria turn it into something that the plants can use, and the plants will use it, get eaten by the animals. The animals poop. The poop goes back down, gets converted by the bacteria, and so on. So you can see this really well if you've ever kept fish tanks. If you keep them properly, typically what you have to do is have some sort of filter to clean the water, and this bacteria, this beneficial bacteria. And this bacteria can help to cause this cycling to occur. We usually refer to it as cycling a tank. So you are setting up the nitrogen cycle in your fish tank when you properly take care of it. That's why as you do water changes, you can remove excess nitrite and nitrates, because ammonia and nitrite are toxic to fish. Completely toxic. If you have even a little bit, it's going to burn their gills and they're not going to be able to survive for very long. So by adding these bacteria and adding plants in, you can help to regulate the cycle of your tank better, enabling them to survive. And the last cycle we're going to talk about is the phosphorus cycle. The phosphorus cycle, all organisms need phosphorus. If you remember back earlier in the year, we said we had adenosine, triphosphate. This phosphate uses phosphorus. So phosphate is a phosphorus compound. And phosphorus is going to be absorbed into the air as aerosols. So for example, this volcanic eruption releases phosphorus into the air. And this phosphorus is going to be used by different organisms. Typically we find it in soil as well as oceans and rocks. And as it dissolves into water and things like that, it's going to be used by our food webs, and it's going to, as it dies, be back absorbed into the soils and into the rocks where it can be used again. So this is all we have for this video. So if you have any questions, feel free to email me.